Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start. Let me turn on my preview screen and then I would be okay. To Geeks for Geeks. Okay. First question. Okay. The viewer count is very less, so we would wait for until at least 1 more minute and then we would start right away. Okay. सो फर्स्ट क्वेश्चन में मेरा आउटपुट सही रहा, टेक्सटिंग कंसिडर में सबमिशन क्लियरली दे रहा था. ओके मैंने बीएफएस पर किया सेम इंट्रो. पहली वाली बात, पहले वाला शायद डीपी से बनेगा. ओके आई थिंक 4 कॉर्नर से रिकर्शन होगा. ओके 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 गुड टू गो. ओके so as soon as the viewer count is more we would start right away. Okay, so how was the question? Can I have a quick discussion about the question? How was the question itself? How many of you were able to solve? How many of you tried? First with BFS and second with stack. Okay, good to go. And anyone else? I just got one reply. I expected a rain of replies. First one is linear, one in solution. Okay, those who know the solution, please don't reveal it. Please, humble request. Simple question with tight constraint. Okay, questions were easy but constrained. Good to go. And we would start at 8-5. Okay, those who are waiting. 0-1 solution. First one is where if we got logic we can do with someone if else. Second one stack. Okay. Krishna, congratulations. I think you have solved both the questions. Okay, good one, bro. Anyone else? Can you start with the second one solution? Actually, the thing is that whenever you try to give a contest, the first question you should try is the simple one. Okay, because it warms you up. It is just like running. Whenever you see an athlete, he at first runs at a slow pace, okay, and after a few moments then he starts running. Okay, in the same kind, CP is a mind sport. Okay, this question all call this question problem solving is a mind sport. Okay, so you should start with the easy one. Okay, that's why I always it is recommended to start with the first question. That's why. Okay, 8-5 and we should start. Good to go. Okay, so the first question. Fill the matrix. So we are given a matrix with dimensions n cross m filled with zeros and one position with 1 having coordinates x and y. Find the maximum number of iteration in which the whole matrix can be filled with ones. Okay, in each iteration 1 can be filled in all the 4 neighboring elements of ones. Good to go. So what the question is trying to tell us is, at first we are given a matrix. Okay, let me draw a matrix itself and then we would see. Okay, good to go. Okay. So now let us try. So suppose that this place is the one which is filled. No, let me take this place. Okay, suppose this place is the one which is filled with a cross itself. Okay, which is filled with 1 and others are filled with 0. This is what the question is telling. We are given a matrix filled with zeros and one position with 1 having the coordinate x and y. So I won't be filling everything with zeros and with 1 so that it will not be visually that much great. So what I want to tell is just fill one position with the cross. Okay, and we would move ahead. Okay, moving ahead, what we can see is which, suppose let us start filling this. So what would happen is this one, this one, this one, okay, and then this one. Now fill this with the other four places, this side, and this side. Now this side, and this would be this side, and this would be this side itself. So this would be the first thing which would be able to cross the boundaries itself. That is what is telling now. Can be filled with all the, find the minimum number of iteration in which the whole matrix can be filled with one itself. Okay. So you need to tell the whole matrix when it can be filled. Good to go. So you can see that if it got the first position, which is at this position. Okay. So it pointed to this position and still the matrix is left. Still the matrix is left. So we know that ye samne wala, the closest point, is not useful enough. So if we can fill the farthest point, then all the points would be automatically filled. The same thing that goes that if a teacher is able to explain the most weakest boy, then if he can explain to him, then all the brighter ones will already be explained. In the same way, if we can fill the farthest point, then the closer point would already be filled. Am I clear with this? Why should we consider the farthest point? Can I have a quick +1 in the chat? Why we should consider the farthest point? Okay. So now we can consider the farthest point. But if we need to consider the farthest point and the closest point are not useful enough, so what can we do is we can take out the farthest point and can we go till can we go till this point? Is this good to go? Can we go? Suppose this is the farthest point. So instead of going all around this matrix, can we go at this position, this side, this side, this side, this side? Am I clear with this? Am I clear with this idea or not? Those who have already solved this, no problem. But those who are not solved, those who are able to solve, just give me a +1 so that it would be clear that I am able to tell you. Okay. So we need to take out the farthest point. Okay. Now moving ahead, what we can see is there is a thing known as distance. So we can move in only 4 directions. Either this side or this side or this side or this side. Okay. And this is where this was a prerequisite. Okay, this question is hard enough if you are not well acquainted with problem solving or with data structure or with competitive programming or with DSA. If you are directly approaching this, it is difficult enough. Okay, but if you are approaching this with an experience that you have solved numerous number of problems, then it is comparatively much easier and you would be able to solve it within 2 minutes. Why so? I am telling you. Because there is a thing known as Euclidean distance. If you read this term in class 9th or 10th, there is a term known as Euclidean distance. Suppose this is a point and this is a point. So what is the shortest distance between these 2 points? Is this, and this is known as Euclidean distance. I think everyone has read about this. But suppose what you can do is, suppose there is a chessboard. Okay, suppose there is a chessboard. Okay, suppose there is a chessboard of many. This is not a chessboard actually. So suppose there is a king. Suppose there is a king, and king can only move in 4 directions. Either this one, either this side or this side or this side. 4 directions. Okay. Now suppose king wants to get at this position. So what would be the shortest position? What would be the shortest distance? The shortest distance is known as the Manhattan distance. Manhattan distance. Okay. Manhattan distance itself. Okay. Now you would tell me, how do you know that it is the Manhattan distance? Because it is known as King's distance. It is not King's distance actually. The King's move. Yeah. King's move, or not actually King's move. It is like king can, the shortest time in which the king can go to a particular position, and this is known as the Manhattan distance. Good to go. Manhattan distance means the shortest distance if we go like this, in either of the four direction. Neither this, neither that. Okay, not inclined. Good to go. Now, the thing is that you should calculate the Manhattan distance of all these positions just to be safe. Okay, diagonally नहीं जा सकते क्या? No, we can't move diagonally. It is already written. Find the number a dimension filled with zeros and ones with one having coordinates x and y. Find the minimum number of iteration in which the whole matrix can be filled. In one iteration, one can be filled in all the four neighboring elements of ones. All the four neighboring elements of ones means, all the neighboring of four elements of ones means, suppose this is the, wait a second, I am telling you. Suppose we are at this position. So all the neighboring four elements means at this position, at this position, at this position, and this position. This means, so this is like moving, we can only move this side, this side, this side, this side, this side. So what we can do is, we can consider each point and calculate the Manhattan distance. And then what is the formula of Manhattan distance? The formula of Manhattan distance is the absolute value of x2 minus x1 plus y2 minus y1. Okay. Okay. And this is not trivial, to be honest. Okay. If you know this concept and if you are aware of this concept, then it is very trivial. Otherwise, it is not trivial. The only thing that is trivial is you were not required to produce, you were required to produce just the result. You were not required to produce the matrix. So the normal thing which should come to your mind is not doing the graph and all. Just think with a little bit simpler approach at first. At first, you should go with a basic, what you can tell, basic constructive one, basic constructive. After that, you should move to the harder concepts. Good to go. राजा तो जा सकते हैं ना? Yeah. The king can move in all the places, but I just gave you an example, okay, so that you can remember. Now the thing is that suppose you have not solved this question, okay, and the answer is already known to you. So what is the use? Did you learn the concept? You learned the concept, but you were not able to use because you already knew the solution. Okay, you learned the concept, but you will not be able to use this concept because you already know this concept. So what I did was, I researched some problems. Actually, I didn't have to research because I am what I can tell, I regularly do competitive programming, so I come across many problems which I actually remember. Okay, so what I did was, I took out a problem for code forces, and the problem name is Manhattan subarrays. Okay, this is a problem which came in educational round 111, rated for div 2. So this is a great application of Manhattan distance. This is a very great application of Manhattan distance. Just search that Manhattan subarrays C educational round. If you're not able to come up with this question, then text me on LinkedIn. My LinkedIn ID is Siddhartha Hazra, that is already given in the contest page. You text me on LinkedIn, I would provide this link, okay? And you would just apply this, okay? Just apply your Manhattan distance one with the Manhattan distance concept on this problem, so that main topic would be very clear. Main topic would be absolutely clear, and you would be able to solve other consecutive problems too. So this one is solved. You learned a new technique or a new thing, and then I gave you a question such that you can practice. Okay, so can I have a quick +1 in the chat if this is all clear, and we can move to the second question? Why BFS don't work? Why BFS didn't work? BFS should work, actually, to be honest. BFS should work. Don't know why it didn't work. But the thing is that BFS didn't work because it might be the case that after coming at this position, then it is like a virus. Okay? It is like a virus. It might be the case that you have not implemented it correctly. Yeah, Ankit Sharma already implemented it and got an AC. So it is like a virus one. So you need to handle each test cases properly. Okay, so can I have a quick plus one in the chat? Can I have a quick plus one in the chat if I'm clear till this point or not? Can I have a quick plus one? Then we would move to the next question. I didn't show you the code because the code is absolutely simple. Just take out the 2 points, x2 minus x1 and y2 minus y1, and consider all the points and you would get your answer. Okay, if you want me to show the points, and it is okay, I can show you. Okay, leave it is homework. Can I have a quick plus one for more people? At least 10 of them. 50 are watching. I want at least 10% attendance in plus one. Okay, can I have a quick plus one in the chat? 10 people, and we would move to the next question. I applied BFS and it gets solved in 0.9. Plus one, okay. I was getting correct answer on extreme constraint, but on summation it gave clearly. Okay. We would be waiting for 1 minute. After that, we would be resuming our session. Okay. So that if anyone got any confusions, why can't we take only the corners in question one? You can take it just to be on the safer side. I compared all the points and it was bound to pass on the time limit. So I didn't care why to optimize upon that. Please solve with BFS first. Well, if I can give a simpler approach to a particular problem, then do you think that solving it with a complicated approach would be of much use? Why not learn the simple solutions? Of course, sorting problems can be done in other ways, constructive ways too. But if sorting is proving to be absolutely short, why to move ahead? Anyone who wants me to solve with the BFS, then can you can give a plus one in the chat, then we can move ahead. But what my view is, if you can solve a particular problem in constant time, why to go with the BFS approach? Okay, moving ahead. This was a kind of implementation problem. Just draw out the different cases, and it would be an implementation problem. Okay. So can I see what all approaches did you try for this problem? Can everyone say me if what all approaches did you try for this problem? It would be very helpful if you tell me what all approaches did you. But clarifying that approach is needed. Clarifying that approach is needed. Okay, I can clarify that approach, but I too need some time, at least 15 minutes of time to think actually. I too need at least 15 minutes of time to implement the solution, to tell you the solution. But don't you think that it now is 8:20 and adding 15 minutes to it, then again adding 15 minutes for explanation, then it would be 8:50. And then after 8:50, we would be starting with the second question. So I don't think that would be much helpful. So if you want that approach, I can solve it by myself. I can give you on the LinkedIn. If you want. Absolutely, no problem. But solving now only is not a good idea. But clarifying that approach is needed, yeah. So say someone told stack of operator and value recursion if similar problems comes one after the other. I immediately thought and then I went blank. I didn't know how to implement them. Yeah. Okay. So what is the thing is that if in the problem, if you ever saw this parenthesis matching or removal of brackets and all, always you should think about in the version of stack. You should take the help of stack. Ever, if you see a problem where you need to delete the brackets, the first approach that should come in your mind is brackets. Okay, not sorry, that's really sorry, is stack itself. Okay, good to go. Moving ahead, how can we solve this using stack? Okay, we are given a valid expression containing only binary operators plus minus multiplication and division operands, and we need to remove all the redundant parentheses. A set of parentheses is said to be redundant if removing them does not change the value of the expression. Okay, so suppose there might be the case, I generally do it to be on the safer side when I am doing competitive programming in a contest. To be on the safer side, I uselessly use brackets. Okay, so but it is not needed. So in this question, it is telling me to remove that useless brackets. Okay, the operators plus and minus have the same priority, and multiplication and division also have the same priority for this question. Many test cases pass, only one left, but due to time I couldn't solve. Maybe there was a little issue in my code. Absolutely, just need to be little bit. I solved using stack. Ankurna, can you tell me how did you solve without stack? Because I am curious too. I too want to know how did you solve. I don't want to check you actually. I want to know how you solved using stack without stack. Because whenever I see a problem like this, I don't think anything else. I just try with the stack itself. So can you tell me how can you solve with stacks? I am curious too. I don't want to test you. Don't take it the other way. I just want to know how did you solve that. And I think it would enlighten many of us. Okay, good to go. So you can see that the outer stacks are not useful enough. But multiplication stack is useful. Okay, so this multiplication stack is needed. So we would be moving forward. Okay, recursion. Yeah, same thing. So after that, this C is nothing. So this one. Okay, so now we would be dividing this problem. In the case of different cases. Okay, moving ahead. Suppose there is the case 1. The first thing that comes in our mind is case 1. Okay, what is case 1? Case 1 is that if a normal operand A, B or C on anything operand is enclosed, only a operand is enclosed with a bracket, we would be removing this. Okay, and case 2 itself, I would be just writing 2 because I think case 2, case 3 is damn difficult. Okay, suppose a bracket is enclosed with another bracket. Suppose a bracket is enclosed with other brackets. Whatever be the thing at this point, a bracket is enclosed by another set of brackets. Okay, done. Then what we want to know is, suppose there is plus 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 plus, example A plus B plus C. Okay, so if there is a bracket at this point, don't you think it is unnecessary? It is unnecessary. The main idea was to break down the problem into small problems. For example, stored A dash and send it to recursion, and for B plus C it send me back to the then B plus C and first operator. Yeah. Absolutely. Okay, we would be moving ahead. And Ankur Rai told a great approach. What you can do is you can comment on this stream your approach. Okay, because your approach is very much interesting enough. So you can comment your approach with a code itself. So it would be helpful for others too. Okay, good to go. So if there is plus plus or minus minus or into multiplication, so it is we would be removing like plus is outside the bracket and the bracket is useless. Yeah, so that's what we are doing. So if it is A multiplied with B multiplied with C and multiplied with D, so if we come across a bracket at this point or this point, then these all are useful, these all are useless, so we would be removing this. Now what is the fourth case? The fourth case is that suppose there is a plus 1, okay, and then it is enclosed in a bracket. So we know that if outside there is plus and it is enclosed in the bracket, then removing all this does not produce any harm. Good to. Now moving ahead, we would be taking care of the situations like there is a minus before the bracket. So what is required is, I am always telling before the bracket, next the bracket, before the bracket, after the bracket, middle of the bracket, all these things. So what you need to do is, you need to store the last operator. First thing you should do, and you should store the next operator. This is the first thing. This is the first thing that you would need to solve the problem. Okay, you would need to store the last operator, you would need to load the next operator, so that you would get a proper idea at a particular position. So what you can do is, you can simply start with -1. So if that is an operator, then you would be updating that. If it is not an operator, then you would be, suppose I would be showing you, suppose for loop, this is a normal for loop. So at first you would be initializing x with -1. Good to go. Then what you would be doing is, you would be initializing an array of last of n, and then what you would be doing is last of x, sorry, I'm extremely sorry, let me remove it. Last of I is equals to x itself. After that, after assigning, we would be changing it. Okay, if operator, then x is equals to an operator. So what would this do? Suppose it is a -1. So if there is no operator, it would be acquired with -1, -1, -1. Then if there is an operator, at that position, it won't be affected. Okay. At the next position, it would get activated. Why so? Because at first we are assigning, then we are updating. So even if there was an operator at a particular position, it won't be we won't be modifying it, and then we would be assigning it. So what we are doing, we are at first assigning it, we are updating it, then moving on, assigning it, updating it, and moving on. So there would be a delay in updation at the next approach. So is this clear? So is this idea clear? How can we store the last operator? How can we store the last operator? Is this one clear? Can I have a quick +1 in the chat if this is clear? Ankur, you can't share your links or your code here. Okay. The first thing, because YouTube chat does not allows it. And the next thing is that you can call me brother itself. Okay. So that we have a proper connection between us. Okay. Is this idea clear? How can we store the last operator? How can we store the next operator? Just the idea. I would be showing you the code, just the idea. At first we would be assigning it, then we would be updating it. Just the idea. Is this idea clear? I would be waiting for more +1. If anyone has any problem, then you can say me. You can ask me directly. No problem. Okay. We would be moving ahead. So thing is that what is the same thing what we can do is, we can do the same thing in the reverse order. We can suppose the last operator can be done from going this side. We got a point, updating it, and then we are assigning it. Same thing. So same thing for the next operator. What we can do is, we can iterate from the back itself. Next operator, we can take a different array and we can assign a next from the back itself. Good to go. So now next and the last one is done. Okay. Now I would be showing this code for this only. Why I would be showing this? Because this implementation is very long. So what you need to do is, I would be breaking down our problem into small test cases. Good to go. So these all test cases would be handled. Okay, so I would be just showing you the code for the last operator and for the next operator. Okay, so what we are doing is for the last and the next operator, what we are doing is we are at first initializing with -1, and then we are initializing with the L itself. Okay, and then after that we are updating it, and we are doing the same thing from iterating from the back itself. We are iterating from the back and we are doing the same thing. Okay, till this point we are clear. Okay, we are clear till this point. Okay, now the next thing is that what should be our approach. Okay, now we would be breaking down the problem. There would be three kind of things: opening bracket, closing bracket, opening bracket, closing bracket, operator, operator, and operand. Good to go. These all things would do. So if we, what we need to do is we would initialize with a stack. We would initialize a stack and stack of integer. So what would be the most useful thing to store in the stack? We would use a stack to solve it. But in the case of balancing the parenthesis one, balancing parenthesis question, if you have made this, so what we were doing is we were storing the brackets character itself. So here what we should store? Can you tell me what should be the most useful thing to store? The most useful thing what you can store is the position. You can store the position itself. Okay, then you can access the character also, and then you would know also this bracket belongs from which position. Good to go. So now if we got an opening bracket, we would definitely push it in the stack, because at first we don't know that if it is useful or not useful. It might be the case that it is useful. So at first we are pushing it to the stack. We would push to the stack. Okay. This case, Ankur Rai used two-pointer approach to get first strings before and also storing the pointer and to take decisions on upcoming recursive code. Yeah, you have break down the problem and then you were doing with the two-pointer approach. Yeah, I can absolutely understand. Okay, so moving ahead, if it is an operator, okay, if it is an operator, what we can do is, if it is an operator means plus, positive, addition, subtraction, multiplication, and division. So what we can do is, if it is an operator, we need to save its position. Okay, so what we would be doing is we would be making an array of plus, multiplication, addition, division, okay, and then multiplication. So suppose we got a addition at position number 29, so we would be updating this 29. We got a subtraction, so suppose we got a subtraction at position 10, so we would be updating this. Okay, what do you mean by useful or not useful? Okay, what do you mean by useful and not useful? Useful means that it would be intact in our answer. It useful means it would be intact in our answer. I'm showing you. Suppose this is the thing known as useful or not useful. So we know that this bracket and this bracket and this bracket is of no use to us. Why so? Because if we remove, or if we keep it intact, the equation would be same. If we remove it, the equation would be same. So what we can do is we are calling this kind of brackets not useful. Why? Because keeping them or not keeping them we won't be able to differentiate. Okay, it won't be able, and in the case of our question, we need to remove all this kind of brackets. So the brackets which we don't want to remove and it would affect our main equation, we are calling it useful, and the brackets which would be there or not there, won't produce any effect, we are calling it not useful. Okay, I hope I am clear, Arpit. Okay, same thing, moving ahead. So if it is the opening bracket, we would push in the stack itself. If it is an operator, we would save its position. we would save the location. We would save the location of it. Good to go. And then if it is if it is an operand, we know that in the final one and in the initial one, the operand would be intact. We are only here to remove. We are only here to remove yeah, brackets. We are not here to remove the operand. And whatever be the operand, suppose it is A, B, 100, 210, 100, 200, whatever be the operand, it won't be affecting our answer. Whatever be the operand, either it is X, Y, anything be the operand, it won't affect our answer and it won't be removed also. So why to use our brain upon that? We won't be using our brain upon that. We would be just ignore the operand. We would be just ignore the operand. Like your ex ignores you. My ex also ignores me. Okay, good to go. Ignore. Okay, good to go. So moving ahead, we would be deleting this. Okay. Next thing is that we would be hitting this closing bracket. Okay, we would be hitting this closing bracket. So if we hit a closing bracket, at first we should know that suppose this is a closing bracket. Okay, so what we need to do is, at first we need to know what are all the operators that reside between these two brackets. Okay, because that is important. Suppose this is an opening bracket, this is a closing bracket, so we need to know the operators which reside between these two brackets. Okay, suppose it is multiplication, division, anything. Okay, anything, we need to know that. Okay, how would we know that? In the stack we have stored out the position. Okay, so this would be the current position, and in the stack, from the stack top element, we would get the closing bracket position. Top element would tell us the closing bracket position. So let us do this in case of closing bracket. What we would do is, the current index would be index of closing. Okay, and the top of stack would give us the location of opening bracket. How so? Let me tell you. Suppose this is the opening bracket, plus minus into multiplication this 0 1 2 3 4 5 6 7. Okay, so this is an opening bracket, we would push in the stack, and these operators would be, we won't be caring about them, we would be just be storing the position. And then again position 3, we would be pushing it in the stack, and then the 6 itself. So we got a closing bracket. So 6 is the current index is the index of the closing, and the top of the index and the top of the stack is giving me the location of the opening bracket. Can you see that? This is closing, this is opening one. Okay, this is how we are getting the information of the position of opening bracket and closing bracket. Okay, next thing what we are doing is, we need to know close opening bracket, top. Okay, next thing we need to know what all operators reside between opening and closing. Okay, what all operators reside between opening and closing. Okay, so what we can do is, we know the index of this, and we have already saved the last index of the operators, so we can compare the location of operators with this position. Okay, and if the location of operators is more than the location of opening brackets, suppose the location of opening bracket is this and the operator's location is at this position, so we know that this index would be greater than this index. So if the value of this index is greater than the previous index, then we know that it exists between this. Okay. Now we have completed the main thing. Now we would be implementing a lot of nested if else, which is difficult to explain in the pseudocode, and we would be implementing all these cases. Okay. Am I clear till this point? Can we move to the implementation now? Can I explain you the implementation now? Am I clear till this point or not? Can I have a quick +1 in the chat if I'm clear till this point? Can I have a quick +1 in the chat if I'm clear till this point or not? Then we would move to the implementation. Okay, good to go. The first thing what we are doing is we are initializing the size of the string. Okay, and next we are implementing an answer. Why answer? Because at a particular position we aren't appending the whole answer. So what we are doing is we are telling if we want to include that bracket to the answer or not. Okay, so what we are doing is at first we are making everything true, because at first we are saying that everything, we are accepting everything is okay itself, and then this last operator and the next operator, and this thing has already been explained. Okay, implement it in Java if possible. Actually it is possible to implement it in Java, but I am not well acquainted with Java. Okay, I started off competitive programming using Java because I knew Java, and then I switched to C++, and then for now I have 80% of the Java I have forgotten, only 20% I remember. That's why. I'm sorry, extremely sorry. Time. Okay. So here I do a stack itself. Okay. Then I do a sign one, and then I do a 0 one. And this would be told why this is doing. And this sign one, what we are doing is we are storing the position of the last operator. We are storing the position of the last operator. And then checking on if this is multiplication, addition, division, checking on every point. What we are doing is we have made a vector of character and we would be checking everything. Okay, and this cost is very small, so we can append it. Okay, now the thing is that we would be resetting MP and storing the last position of the operator itself. We would be storing the last position of the operator itself. Please explain how Manhattan distance work. Okay, Satyam, just tell me a thing. Can you tell me how can if I ask you, you have all if I know that you have not read about I know that you have not read about Manhattan distance, but you have read about Euclidean distance in your 8th standard or 9th standard. So if I ask you, can you tell me how an Euclidean distance work? Is it possible? Just tell me. Is it possible to explain how a Euclidean distance works? Okay. It is, I can't, I would be trying my best to explain you, but I don't think I am eligible enough to explain you that much basic. Okay, but I would be explaining you after I explain this. Please bear with me. After I explain this, I would be explaining how Manhattan distance work. Okay, just bear with me. And I don't think I would be able to explain, but I would be trying my level best after this speech. Okay. Okay. So if it is an opening bracket, we are pushing it in the stack. If it is an operator, we are ignoring it. If it is a closing bracket, what we are doing is No, I mean in first problem. How Manhattan distance works in the first problem. I think you should I think you should rewatch that video. Then you would know why Manhattan distance work. How Manhattan distance work. Because I have already explained and I waited for doubts itself. Okay. So I don't think I can take the doubt after this after on the process of explaining the second question. I don't think it is right from your side. If you faced any difficulty, you should have informed me in the first question itself. Okay, I'm extremely sorry. Okay, so if you still have any doubts, you can ask me on LinkedIn. Okay, so int I is equals to st dot top and j is equals to the current position. Okay, current position, and then we are taking the next operator and the last operator, and then we are popping that one. Okay, now if the sign if the position of the operator is greater than the closing bracket, the opening bracket, then we are making mp is equals to 1 itself. Okay, and then we are making ok is equals to false, and if at any position any of the case is true, we won't be appending that particular bracket sequence. Okay, now what are the bracket? Suppose a bracket is surrounded by a bracket. That is the first condition we have talked about, and that is already implemented. If s dash I minus 1 and s dash j plus 1 is a bracket, so we won't be appending that. Okay is 1 and we won't be appending. So, and there is no operator in between the operand. Okay, two brackets. I'm extremely sorry, Satyam. Sorry if I sounded rude, but I don't want it to sound rude. Okay, I'm sorry. Just what is MP tracking? Yeah, MP is tracking that what are all the operators that exist between the two opening and closing. Just see this. I told you that if the position of the operator is greater than I, what is I? I is the opening bracket. If the position of the operator is greater than the position of the opening bracket, we are making that particular thing 1 itself. Okay, and if nothing is getting 1, that means no operator exists between the opening bracket and closing bracket, and this is what is this. Am I clear? ZOSO, can you please acknowledge if I'm clear? Okay, and the next thing is that last is minus 1 and next is minus 1. Suppose there is no operator after that or before that. If there is no operator after or before, then we can carelessly use brackets, but it is not important. It is not needed actually. So we can remove all that. Okay. And the next thing is that if there is a division before, then this is the thing, that if there is a division before, it would be at this position and nothing would be done. Okay would remain false. Okay, and the next thing is that we have already considered, suppose there is a -1 at first, and there is a bracket. So we know that if we open this bracket, the whole thing needs to be changed, because that is -1 and everything needs plus should be made to -1 and minus should be made to plus, and we would be inverting to that last minus. If there is a -1 at this side, then we won't be doing anything. Okay, and then if there is a minus and there is not any plus, then we know only multiplication would remain. Why multiplication would remain? Because we have already considered the case for division, so division won't remain till this point. If there is a minus front, so the minus won't remain. Only thing that remains is multiplication. So A multiplied with B multiplied with T and 3 multiplied with T. Okay, Taliban gonna take over Afghanistan thoughts. Okay, I don't think I would be able to make any thoughts. Okay, so else if the last one is -1 and the last one is can you please stop spamming? Sir, please speak Hindi. There are many coders who don't understand Hindi. That's why I need to tell in English only. But मेरी English बहुत खराब है. Okay, the last one is -1 and the last is plus. Okay, suppose at this side there is nothing. At this side there is nothing. Last one is nothing, and whatever be the position at this side, whatever be the position at this side, there won't be happening anything because there is nothing at this there is no operator at this side. Okay, so we would be removing that bracket, and suppose it might be the case. Sir, please speak Hindi. Sir, please speak Hindi. मेरी हिंदी उतनी भी अच्छी नहीं है. मेरी हिंदी भी अच्छी नहीं है, मेरी इंग्लिश भी अच्छी नहीं है, मेरी सिर्फ बंगाली अच्छी है. Okay, so after all this, considering all these cases, if OK is true, then answer would be made 0 and J would be made 0. We were doing what we are doing. We are making all things 1 true, and then we are making 0 itself. We are making this false. And now what we are doing is, if it is true, we are only appending the characters to the answer which is true itself. Else we won't be appending that to the answer, and at the end we are returning that answer. Okay. Siddhartha is Captain America. I don't think so. Okay. Good to go. Anyone has any difficulty? Okay. 2 problems are explained. Now I am open for discussion about anything. Tell me anything. Open. OMG Bengali Roshogolla. Yeah. We can do a little chit chat. Can you tell me? Anyone have any doubts? Any doubts that persists? Please tell me if there is any doubts that persist. Else I would be turning off this session. Okay. Sir, same concept I used, but I took decisions after recursion. Brought answers for small problems. By recursion was returning struct of a structure of first OP last operators. Yeah, same thing. Are this solution posted somewhere? So what you can do is, I can't post the solution at this chat itself. So what you need to do is, you can ask me on LinkedIn, or if you want, just comment it or comment on the video, the comment section. After the stream, the comment section would be activated, and just comment on the video, and I would be providing the solution for both the problems. Okay, just commenting that, and everybody would be able to access that. Only one comment also, and I would be able to do that. Sir, so Taliban now, okay. Sir, open. Taliban gonna take over Afghanistan thoughts. Okay. So I don't think Taliban and all things are so they are existing. I don't think so. They are just an agenda of the politicians. The religion and the Taliban's everything are all the agendas of the politicians. They use it to acquire votes. It is just my thought, personal thought. Sir, your LinkedIn, my LinkedIn is Siddhartha Hazra. That would be found on the contest page. You can connect on me with LinkedIn. We can do a chit chat about everything. Okay. So am I clear till this point or not? Can I have a quick +1 in the chat so that I would be turning off this session? By the way, Indian Traveler made this stream funnier. Thank you. Coding seems to be a serious sport, but you made it funny. Okay. So one more thing at the end, if you liked my explanation and everything, if you liked everything, all my explanations, and if you the thing is that I invested so much time, so I expect appreciation or a positive criticism. So what you can do is, you can comment your feedback after this stream is over, or you can comment your feedback on the stream itself. Okay. Okay. So am I clear till this point? I am closing off this session. I don't think I don't think any more queries exist. I am just lingering this whole session. Sir, I've explained all my connection request limit exited. Next thing I will get request. Okay. Okay, sure, no problem. Taliban not gonna explain CP, concentrate on the code. बट एक चीज में कंसंट्रेट करने से बोरिंग हो जाती है, सच बता रहा हूँ। बहुत ज्यादा सीपी भी करोगे, बहुत ज्यादा कोडिंग भी करोगे ना, माइंड ब्लॉक हो जाता है। मैं खुद भी पबजी खेलता हूँ, टू बी ऑनेस्ट, आई एक्सेप्ट दैट फैक्ट। मैं खुद भी पबजी खेलता हूँ। ओके, थैंक यू सर, यू आर सो हम्बल। आई एम नॉट अ सर, आई एम अ बीटेक स्टूडेंट लाइक यू, दैट्स व्हाई। आंसर, you are so humble, nothing at all. I'm just a human just like you. And I am too learning also. I am also learning like you. Okay, that's all for today. Thank you and have a nice day. Good night. Meet you in the next contest, post contest discussion. Okay, thank you.